So here's a refreshing break. Maybe even take you back to physics a little bit. For example 4, it's talking about exponential decay. So we have a base that is a decimal, which means the graph's going down. Yeah, if you know about half-life decay, I believe you should have learned about that sometime in the past. Certain isotopes break down in rock so they can age really, really old rock using uranium, things like that, because every so many years, half of the radioactive isotopes decay. So basically the idea is that whatever number you have to start with gets cut in half and then cut in half again and cut in half again and cut in half again. So it becomes half, a quarter, an eighth, a 16th, a 32nd, a 64th, and it keeps going down in that nice little curve that you saw in the beginning of this chapter when you have a decimal as a base, and never actually reaches 0. It just keeps getting cut in half but never gone completely. So that's kind of the idea that we're looking at here when we're talking about exponential decay. It's something that is being reduced. And then, of course, our variable is the power. So this equation in example 4 is kind of nice because they just give us a formula. They say that the pressure in kilopascals at any spot in different altitudes is equal to 101.3, which is standard temperature pressure from, if you're in chemistry, you'll remember that number, times 0.88, so that would be a percent of this, to the power of whatever the altitude is. So this is your basic run-of-the-mill. We can plug in the number and use our graph to solve it because we don't want to guess at an exponent. It tells us in this question they're looking for when is the pressure 10. Well, the pressure's there. So I'm going to write 10 into that one, copy down the rest of the formula. And I can't simplify these because this is what's being raised to the exponent. So I'm kind of stuck. But what I can do is I can take the 10, move it over there as a negative, and I can have this whole thing equal to 0. So 101.3 times 0.88 to the power of h minus 10. And since I made it equal to 0, I can use my graphing calculator and I can turn it on first. I always forget that part. Then I'm going to plug in this equation that I have created. 101.3 times 0.88 to the power of my variable. Page over so that it goes down to normal, minus 10. And if I graph it, I'm watching here to see that it's computing the graph, and it doesn't show up. But the reason for that is because I've got a scenario where my numbers are not in the realm of 10 and 10 anymore. So I need to reset my equation. Now if I think about this, I'm going to try to ballpark it. It's pretty difficult with exponents, so sometimes what you might want to do instead is zoom. So it says zoom out, which is 3, and so I'm just going to zoom out, and it's working. Ah, there's the line. So once in a while, if you don't really know where to start, you can just try zooming out and you'll be able to see where the line is. Then you can adjust. So obviously I don't really need to worry about, well, this side here. So I could go to my window and I could do my x minimum is 0 because I don't need all that other stuff. And then I can just graph it here, and it's a little easier to pinpoint. Now if I want to pinpoint that exact amount, because that's where y equals 0, and that's what I've made my equation equal to, then I want to go second function calc 0 and move my little cursor so that he's left bound toward the intersection, and then put him on the other side so if he was going right bound, he'd be going toward the intersection. And when I've got that, I'm going to hit enter again when it asks me to guess, and then it's computing the results. Uh-oh, what'd I do? 0, Did I hit it too many times? I wasn't paying attention. I hit it too many times. Anyway, so it says that 0 is 18.1 when x is 18.1 when y is 0. X equals 18.1. And in the question it tells us that the altitude is in kilometers, so that means that 18.1 kilometers above sea level is where I'm going to have 10 kilopascals of atmospheric pressure, which is not going to be comfortable to breathe in.